Excellent. Okay, so yeah, good morning, everyone. Lovely to be here in Ghana. My first time to West Africa, so thanks for inviting me. Um, so this talk follows very nicely the talk by Raphael earlier. So he was talking about land use regression, and I'm going to talk about source apportionment. And in many ways, these two topics are the two sides of the same coin, and they could be used together. We're not talking about using them together here, but that might be an interesting discussion to have with me and Raphael later, but also maybe more generally to think about how we can combine source apportionment with land use regression. There's probably quite a lot of distance we could travel there. So anyway, I should introduce myself. I'm Francis Pope from the University of Birmingham, where I'm a professor of atmospheric science. I've done lots of work in the past on West African air quality, Nigeria, a little bit in Ghana, but this, as I say, is my first time here. So I think it's really important to actually get a sense of what the air pollution situation is like here. And you can see the cloud, the blue sky is slightly cloudy, slightly white sky. We know we're in the Harmattan season. Certainly my chest, I can feel it a little bit. So clearly the air pollution's a bit higher than it is at home. But it's great that Dan and everyone else has organised this conference to talk about air pollution in this important region. And I think certainly if you look at how air pollution is looking, I've looked more in Nigeria than I have in Ghana, but certainly it seems to be increasing and increasing quite dramatically. So it's excellent we're here. I turned up last night, and one of the troubles of turning up late to a conference, I don't know what people have said already, so I'm sure there's going to be a little bit of repetition, but we learn through repetition, so please let me say sorry for that at the start. Right, so I think if you're in this room, I'm singing to the choir. You all know about why we're interested in air pollution. But as I say, there's no harm in repeating this stuff. So exposure to air pollution causes a range of adverse effects on human health, and the estimates vary about how many premature deaths there are per year, but it's somewhere between 5 and 9 million, depending on that. And so, for example, in the UK, in the UK, that's about 40,000 premature deaths per year. I don't know what the numbers are for Ghana, but I'm sure it will be similar, proportional to the population. But not only do people die because of air pollution, they also significant morbidities, so it affects the way we can learn. If we're a child in schools, we have reduced learning outcomes. It affects the way we can work at work, so there's reduced productivity, so it puts a brake on our economy, it puts a brake on our development. And so the mechanisms of toxic action, obviously it can affect our respiratory system, it can affect our cardiovascular system. Some air pollution is carcinogenic. And then there's this growing body of literature, which I'll talk about briefly. It's not about source apportionment, but there's this growing body of work which talks about the effects of air pollution on cognition and mental health. And I think this is one of the big stories going forward. So at the moment, if air pollution costs however many billions per year, if the link between air pollution and cognition is really proven to be strong, then you put another zero on the end, because then you really are affecting how well people work. And since I'm an air pollution scientist from the UK, I'm contractually obliged to show a picture of London in the smogs in the 1950s and 60s. And so we've certainly gone through this chronic air pollution in the UK. It's by no means perfect anymore, but we've gone through these really bad periods in the past. So this was a famous London landmark during one of those 1950s smogs. So yeah, just a few words before I get onto source apportionment. I'll talk about this cognition effect. So I've just got a few articles. Is air pollution making you dumb? Okay, and so the link between air pollution and mental health cognition is getting stronger and stronger. We've done some work of this in Birmingham, as have many people around the world. And so this controversial headline was, is the reason we don't do anything about air pollution is because it affects our brain. So a bit tongue-in-cheek. Again, air pollution rots our brains. Is that why we don't do anything about it? And then pollution may dim thinking skills, study in China suggests. And I think this is interesting for a number of reasons. A, obviously cognitive health, mental health is super important, but also, your ability to do well at school and your economy to do well is very much responsible on how well your population thinks, if we think about it in those epidemiology terms of Raphael talking about earlier. So this is one of these upcoming things. Now, the reason I've gone over this maybe old news is why do we want to know where the sources of air pollution come from? So that's what my talk's really about. So why do we want to know? Why not just care about how much air pollution there is? So the first bit of air quality management is we have to measure how much air pollution there is. So there is outside, I don't know exactly, but let's say PM 2.5, the sky's a bit milky, the visibility is quite low, I can feel it in my chest a little bit, so my guess is PM 2.5 is somewhere around 40 micrograms per meter cube. I don't know, you can check for me, see how well I did on that estimate. But that doesn't say anything about where it came from, so that's where source apportionment will come in. So where does this pollution come from? And if we know where it comes from, then potentially we have a better chance of doing something about it. So is that pollution regional? And a lot of West African air pollution is regional, and regional air pollution is really difficult to deal with because it's not just your fault, it's your neighbour's fault, it's your neighbour's neighbour's fault, and that's quite difficult. But if most of the air pollution is coming from the fire next to you, then that's somewhat easier to deal with, right? You find a different energy source. Not to say that that's easy, because energy costs money, and so that's a function of how much money you have to spend. But that fire there, you have some agency. You can maybe look for a different heating source. You can look for a different cooking source. But you need to know where this air pollution comes from, and you need to be able to do that in a quantitative way. So that's one reason why air source apportionment is super important. And the other one, this is a little bit more thinking a bit further down the line, but one of the really interesting things about air pollution to me is for particulate matter, PM, and particulate matter is this rich mix of different particles with different sources, different compositions. So if you're at the coast, where we're quite close to the coast at the moment, there's going to be a lot of PM from sea salt, and that's not bad for you, we don't think. There's a lot of PM from burning, and you might think that's worse for you. But at this moment in time, the epidemiologists don't know really any difference between the different compositions of particles. And many of you in the room will be chemists at some level, and that seems crazy, right? So we know that chemistry affects health in different ways. So I think we need to unpick these sources, and then we can see what's in these sources and work out some of the health effects. And I really think if there's going to be another Nobel Prize in atmospheric science, then that's where it will be, is understanding the health effects of parts of the particle matter composition. So that's a bit further down the line, but to maybe inspire a few of the younger ones in the audience for where to get their Nobel Prizes in a few years, is looking at that health effect of different PM compositions, okay? Okay, so I'll move on to the lecture proper now. You all know this, The reason I put this slide up here was this was the old WHO recommendations, and as of 2 years ago, they went from there to there. And what this is saying, to me anyway, is air pollution is important everywhere in the world. So don't feel like we're just talking about Ghana. These limit values for PM 2.5, PM10, it is incredibly difficult for the UK. It'll be incredibly difficult for the US. It'll be incredibly difficult for everywhere in the world. So health effects of air pollution is important for everyone. Okay, so let's get on to source apportionment. So this is a picture I took in Nairobi in Kenya. So they're building this new road. So I've done a lot of work actually very close to this road. And so as I took this photo, so where's the different sources of air pollution? So we're outdoors, and where's the air pollution coming from? So we've got construction. You can see the dust coming off the construction here. So very clearly a big source of air pollution is coming off the construction. And yes, construction is maybe a short-term effect, but in your city, there's always going to be construction going on. There's this famous quote, I think it's about London, it might be about New York, but the quote is, London would be a fine city if they ever bothered finishing it. So essentially, you're always building stuff, right? So we've got construction, we've got industrial pollution, we've got residential pollution, so that's indoor pollution going outside, potentially. We've got vehicles causing pollution there. You can't see it very well, but there's some trees back here, so maybe there's some biogenic pollution as well. So how do we know what's responsible for all... How do we know what's responsible what's the main source of air pollution? Here I'd be reasonably comfortable that if you're standing here, your main dose will be because of that construction. But how do we know that? How do we actually prove that? So that's outdoors. Outdoors is super important. And then we've got indoors. I realized this is an Indian house. This was, I was looking on the internet last night to get a diagram of a house. So I've got an Indian house here. So what are the sources of air pollution indoors? And many of them will be universal, many of them will be the same in Ghana and West Africa. So there's combustion sources, so whether that's for cooking or heating, there's cigarette smoke, there's volatiles coming from cleaning products, etc., etc. And then there's also outdoor air coming inside. So lots and lots of potential pollution sources for your indoor environments as well. So how do we do this source apportionment for both the outdoor air pollution sources but also the indoor air pollution sources? And we have these regulatory air quality monitoring sites. So this is the example in the UK. So we've got something called the AURN network. A very nice network, works well, long time series, and that measures the levels of air pollution, but it doesn't tell us anything about the sources. So these techniques of source apportionment are relatively well known, but not many people do them. So if you look in the literature, there's tens of thousands of papers on source apportionment, but actually when you then get into a regulatory side of it, so does the governments use source apportionment? No, they don't. And why is that? And so I would argue the reason for that is actually doing source apportionment's expensive, both in terms of the equipment you have to buy to do it, but also in terms of the expertise you need to run it. So you need a fully trained research staff to do it. So you have these monitoring networks. And so then air quality sensors come into this space. So, and again, I'm singing to the choir here. Most of you will know this very well. So what was the promise, what was the vision of these air quality sensors? So essentially, what's the advantages of these sensors is they're cheap, they're small, both in size and weight. They've got relatively low power requirements, so you can run them on batteries, you can run them on solar, you can run them on mains as well, of course. And at some level, there's low technical expertise required. I'm not sure that's absolutely true, but certainly that was the vision, that these things can be kind of plug and play. And so with those four ingredients, that gave us all these potential applications. And some of these have been realized already. So greater spatial resolution, we've seen lots of great examples of this already, and I'll show a few more coming up. Greater temporal resolution, so again, lots of great examples of that. Mobile devices, so these things, again, they're small enough, they're low enough power, so you can put them on a battery, you can put them on the back of your bike, or you can put them on the back of your van, and you can measure air pollution as you go around the city. So you can get that really good spatial variation. Some of them are cheap enough that you can almost treat them as sacrificial devices. And so I was talking to colleagues earlier about whether we should actually start worrying about how much these sensors are being used in a sacrificial way. So are we actually building up a lot of this e-waste for a future problem? You can do multiple pollutant measurements with them. I'll talk a little bit about that. You can do indoor monitoring. And you never used to, well, it was always very difficult to do indoor monitoring with regulatory equipment. So if your piece of kit is as big as this, costs £500,000, makes a huge noise, sucks at 20 litres per minute of air, then actually it's very difficult to measure inside houses because A, it's unpleasant to be near, it takes up all your space, and it will suck all the air out of your room very quickly. So these little devices suddenly mean that we can monitor indoors. We can combine with other devices, so we can combine with other sensors, whether that's meteorological sensors or whether that's more sophisticated sensors. So we're doing lots of work at the moment in Birmingham combining air quality with radar sensors to get a sense of how occupancy affects air pollution. And then we start getting into things like citizen science, public outreach with these things, because again, they're cheap enough that we entrust non-scientists, non-technical people to use them.